Okay, so this is the third problem now that we are discussing. If you've not seen the previous two problems, so you go through that because now we'll be solving it in somewhat quick. So the question is, a continuous beam is simply supported at A, B and C, and now this AB and BC is carrying point load, and both point loads are eccentric. This is 60 kilonewton and this is 80 kilonewton. So this is 4, this is 2, this is 5, and this is 3, and this is 5. So we'll denote the names also. This is E, A, B, C, D, and this is E. Okay. So while starting, first we have to draw free bending moment diagram. So as this is a point load, so here it will be a triangle. Same case here also, there will be a triangle. We have to find the height of these triangles. So we'll start with the problem now. Given continuous beam P1 60 kilonewton, and what we have to find? We have to analyze the beam. That means we have to find completely shear force diagram and bending moment diagram. So moment at point D, point load, so it is PAB by L. So 60 into 4, so this is A and this is B in this case. So 4 into 2 by L means A plus B, so that is 6. Moment at point B also same formula, PAB by L. So 80 into 3 into 5 by 8. So the first answer should come as 80 kilonewton meter, and this is 150 kilonewton meter. So this value here is 80 and this is 150, and these both diagrams are positive. Next is fixed bending moment diagram. Moment at point A is 0. Moment at point C is also 0. So we have to find out what is the moment at point B. So we'll use Clapeyron's theorem. So this is the Clapeyron's theorem. Now one by one we'll write each and everything. So MA value is 0, L1 is 6, MB value we have to find out, L2 is 8 and MC is 0. Value of A1 is triangle, so half into base into height, so half into base is 6, height is 80. Similarly A2 is half into base into height, so half into 8 into 150. So this should come as 240 and this should come as 600. Now the most important part is x1 and x2 bar. So now pay attention here. This is the centroid for this triangle and this is the centroid for another triangle. Okay, it is not present at the exact location, it is present at some another point. Okay, now what is the distance of that centroid from this side? This will denote it as x1 bar. and the distance of this centroid from C, this is x2 bar. Okay, so directly it is not 5. You have to find out by using the formula. So what is the formula here? Here only I am writing. For this case, the distance is, if this is A and B, it is L plus A by 3. So this distance here, this is L plus A by 3. So what will be the another distance? This will be L plus B by 3. Remember, this A and B are for this case. If you take this second triangle, and if this is the centroid, then this distance is L plus A by 3 and this distance is L plus B by 3. A and B will vary based on the question. So don't get confused here. Take the respective triangle, identify the A and B, and then apply the formula L plus A by 3. Okay, so now coming back here, x1 bar is equal to L plus A by 3. In the first case, x1 bar is equal to L plus A by 3. So this L is L1 bar, okay, or this XL is L1. So we are taking the first case. So 6 plus 4 by 3, that is 10 by 3. Similarly, x2 bar is L plus B by 3. L plus B by 3. In second case, L is 8, B is 5 by 3. So this is 13 by 3. So this is x1 bar and x2 bar. Now substitute all values. Substituting all values in equation A, that Clapeyron's theorem. So we'll get 0 into 6 plus 2 mb in bracket 6 plus 8 plus 0 into 8 is equal to minus 6 into a1 x1 bar by L1 plus 6 a2 x2 bar by L2. So this is 0, this is also 0. 6 plus 8, 14, 14 2s are 28 mb. This is equal to minus 2750. So upon calculation, mb will come as minus 98.21 kilonewton meter. Minus sign indicates the hogging nature, so we can write it like this: 98.21 hogging. So this is the support moments. Okay, sometimes in question up to here only it can be asked, but if it is asked to draw the shear force diagram also, then the next step we have to start. So now we have calculated the value of mb and the value is coming as 98.21. so this is 98.21. so now connect this with the straight line. This is of hogging nature, so negative. So net bending moment diagram will be joining this 80. This is 150. And this is 98.21. So this is positive and these are all negative. F and G are point of contraflexure. Now we'll have to see how to draw the shear force diagram. So same thing, first we'll draw the given beam. Now on the given beam, we'll apply all the moments that we have calculated. So this is 0. Moment at B is 98.21 and moment at C is 0. This is A, B and C. This reaction will name VA, this VB and VC. So shear force calculation. So same thing, we'll first consider AB, then BC, and then ABC. So this is VA. Here a point load is there of 60, 4, 2. This is B, and moment of 98.21. So what we have to apply here? We'll have to apply sigma MB is equal to 0 and clockwise positive. So VA into 6 minus 60 into 2 plus 98.21 is equal to 0. So from this we will get the value of VA as 3.63 kilonewton. So VA is now 3.63. Now next is consider BC. So this is our VC, this is the point load 80, and this is the moment 98.21, B point 3 and 5. Apply sigma MB is equal to 0, clockwise positive. So it is minus VC into 8 plus 80 into 3 minus 98.21 is equal to 0. So VC is equal to 17.72 kilonewton. Now at last we will consider the entire ABC, and we will apply sigma Fy is equal to 0. So VA plus VB plus VC is equal to 60 plus 80. VA is 3.63. Then this is VB, we have to find out. VC is 17.72 is equal to 60 plus 80, 140. Upon calculation, you will get the value of VB as 118.65 kilonewton. So this is how we have calculated all the shear forces. Now we'll start drawing the shear force diagram. This is the zero line. This is the location of point load. So from this point, what is the value of VA? 3.63. So 3.63. Now constant up to this point, ABC, this is D and E. So constant up to D. Now 3.63 minus 60. So this will give us minus 56.37. So we have to come down, and this is 56.37. Now from here to B, it is constant. Up to B it is constant, from D to B. At B the value is 118.65. So minus 56.37 plus 118.65. So this will come as 62.28 positive. So we'll mark it here. This is 62.28. Same up to here it will be constant. Now 62.28 minus 80. 62.28 minus 80. This will give us minus 17.72. So this will give us 17.72. Minus means below zero line. Then same from E to C, no loading, so constant. Now what is the value of VC? This is 17.72. So minus 17.72 and plus 17.72, 0. So this is a zero line. All the values above zero line positive, below zero line negative. So this is our shear force diagram of the continuous beam. Okay.